Let me show you how to create an asynchronous API. This is a very powerful technique that you should start using in your applications right away. So in this project, I'm going to add a new class, mail service. We're going to use this class to send emails to our users. Now, here we need a method like public void send. Now, in a real application, we should pass a mail message object, but let's not worry about that. Instead, we're just going to print a message like mail was sent. Now, sending an email is a long-running operation because we have to go over the network. Basically, anytime we have to touch the file system or the network, we're dealing with a long-running operation. And we shouldn't run these operations on the main thread. We should run them on a separate thread. So to simulate a long-running operation, I'm going to use our long task class that we created in the last section. Here we call the simulate method, which adds a 3-second delay to this method. Okay. Now, in our main method, I'm going to create a new mail service and then call service.send. Now, this is a synchronous or blocking operation. So if we print another message here like hello world, we're not going to see this until this method returns. Let me show you. So run. We're waiting for the mail to be sent. 3 seconds later, the mail is sent, and now we see the hello world message. So this is the problem with synchronous or blocking code. Now, anytime we have a long-running operation like querying a database, calling a remote service, working with the file system, we should run these operations asynchronously. Let me show you how to do that. So we go back to our mail service class. I'm going to re-implement this method in an asynchronous fashion. So we add another method, public. Instead of returning void, we're going to return a completable future of void. If this method returned an integer, here we would use completable future of integer, okay? Now we call this method send async. So by convention, we add the async suffix to this method, okay? Now, here we should return a completable future object. You learned how to do that in the last video. So we return completable future. Because we're not going to return a value, we should call the run async method. Now here we should pass a runnable object. So we use a lambda, and in the body of this lambda, we simply call our synchronous method. As simple as that. Now, with this single line of code, we can execute this method in an asynchronous fashion. Because when we call the run async method, the task that we pass here is going to be executed on a separate thread on the common thread pool. So if you have an existing synchronous method, you can simply convert it to an asynchronous method by wrapping it inside a completable future object. Now, back to our main method. Here we call send async. Now, because this is an asynchronous method, it's not going to block the current thread. So the moment I run this program, we're going to see this hello world message immediately. Then we'll wait 3 seconds for the mail to be sent. Take a look. So run. We see the hello world message, but what happened to our mail? Well, here we have a command line program. And this program terminated so quickly that we didn't see the result of this task that was executed on a separate thread. We don't have this problem in a mobile or a desktop app because these apps are continuously running until the user terminates them. So to prove to you that our mail was being sent on a separate thread, I'm going to put a delay over here. Let's say thread.sleep for 5 seconds. We should wrap this in a try-catch block. Now we run our program. So we see the hello world message. 3 seconds later, the mail was sent, and then 2 seconds later, our program finished. So this is the benefit of asynchronous APIs. They don't block the current thread and allow us to better exploit our parallel hardware.